I'm Kenton Gewecke. Today in the Live Downdraft First Alert Weather Center, we're going to learn about tornado formation. And we're going to start at the very beginning. We're looking at the big picture here. So we have the United States, which of course our country having the most tornadoes than anywhere else in the world. And to start at the beginning, we're talking way up high in the sky, the very top of our weather-producing atmosphere. It's the jet stream. It's 25 to 30,000 feet in the air, and it's where commercial airlines fly. And this air here is going to be very cold. It's also going to be moving very fast. It can move up to 275 miles per hour at times, and it's also going to be very dry air. Meanwhile, down here at the surface, we're going to have warmer air. It's going to move a little bit slower as well, and it's moving in from the Gulf of Mexico, so it's going to have more moisture. So at the surface here, we have slower air. Again, on average, our wind speeds here at the surface are about maybe 10 to 15 miles per hour. And it's also much warmer, and it has a lot more moisture than at the top of our weather-producing atmosphere, 25, 30,000 feet up. We have very fast-moving air. It's colder, and it's drier. So the difference in these, especially the difference in wind speed with height and direction, that's going to create wind shear. Now, wind shear can then create a horizontal rotating column of air, and now we just need a thunderstorm to roll through and kick this thing vertical, and that's going to create our tornado. So let's talk about what we need there for actual tornado formation. So let's talk and zoom in here and look at let's call it a supercell or a severe thunderstorm. So in order for that to form, we need that warm, moist air down from the surface to be pushed vertical. We need it to rise, and that's going to create condensation, which creates the cloud cover and the thunderstorms. And that actually releases even more heat into the atmosphere, which then rises even higher, and eventually we have a very strong updraft, and we have a severe thunderstorm. Now on the backside of these thunderstorms, we also have a downdraft, and it's, as you can see, a colder air moving downwards from the clouds, and it also has a special name. You might hear us talk about it when we're tracking severe weather on live Doppler rate radar or out in the field on Storm Patrol 8. It's called the RFD, the rear flank downdraft. And between the rear flank downdraft and our very strong updraft here, not only do we have a difference in wind direction, we also have a difference in temperature. So now if you remember that horizontal spinning tube of air, now it has just what it needs to be kicked vertically, and now that's what we know as a tornado.